The focus is going to be on the variant of logistic regression, part 3. We are focusing on 2 more variants of logistic regression today. We call them multinomial and the ordinal logistic regression. Okay, that will be the final variant that we want to talk about. Now, the outline, I've of course have review on, logistics, binary logistics, and, the variant type that we've handled before going into today's topic. Now, let me tell you this. Before now, we've been characterizing relationship between variables, and what determine the nature of the response variable to use is what determine the type, the regression type to use is the response variable. So when the response variable is continuous, we normally fit linear regression. When the response variable is categorical, okay, we use binary logistic. Categorical, when you say we have 2 levels, either this or that, we use binary logistic. When the response variable is a count, we use Poisson regression, okay, when it's a count, okay. But what if in a situation where the response variable is continuous but is bounded in the region of 0 to 1? We use beta regression. That was what we did yesterday. But what is new today? What is new today is, what if in a situation where the response variable is categorical, but it has more than 2 levels and they are not ordered? I'm going to say that again. We got the response variable is categorical. They have more than 2 levels, but they are not ordered. We're going to use multinomial logistic regression. Take a look at this. I'm going to walk you through an example right now. Okay, an example is discipline. Humanities, social science, they are not ordered because there's no discipline that is not superior. Does that make sense? Imagine if your response variable is discipline and you got more than 2 levels. Or race, white, black, or African American, Asian, American Indians, or Alaska Native, and so on like that. We have levels that are more than 2 for response, and they are not ordered. We're actually going to, if you're seeking relationship between a response variable that look like this in relation to some explanatory variable, you're actually going to fit multinomial logistic regression. There's another example, iris species like Iris setosa, Iris versicolor, Iris virginica. Now, do you now understand when the nature of the response variable is categorical and it's more than 2 levels and they are not ordered? Okay, now since you understand the example of that, I'm going to walk you through the model. Okay, the model right now. Okay, now I'll quickly, without wasting your time, the model is going to look like this. It's going to look like this. It's going to be log of pi js divided by that equal to that. But this is what happened. I got so many levels, right? More than 2. But before I start, I'm going to make one level to be a reference level so that I will be comparing every other level with the reference level. So which means I'm going to compare 2 at a time, 2 levels at a time. But I got to make sure I make one level reference. Okay. So now take a look at this. And let me tell you this. When you are talking about, we said with the multinomial means we got so many categories. So that was why if you take a look at this guy here, we consider the count of J categories of Y as multinomial. Each category, they're going to have their own probability. So pi 1x is the probability for category 1. Maybe we're talking about, if we're talking about race, how many African Americans in this community? If I want to find the probability of African American, going to be the number of them divided by the totality. So pi 1s, pi 2s up to pi js, each of these pi represent the probability of each category. And in the model, I'm only going to compare two categories at a time, two levels at a time. But the one I'm going to put in the denominator is the one I'm going to make as a reference. Okay. Now, and you're going to see that I got pi 1x, pi 2x, which means I'm talking about probability that depends on explanatory variable. Okay, now let's have this now. I want to use this example. This example is coming from University of California at Los Angeles. The example is entering high school student make program choices among general program, vocational, and academic program. Okay, now the response variable here is the type of program. How many programs? We got 3 programs. That is more than 2. That's multi levels. And they are not ordered. There's no program that is superior. Okay. Now their choice might be model using their writing score. Now the writing score is explanatory variable right now. And their socioeconomic status. Now you know what I'm trying to do. I actually want to look at the effect of writing score and the socio-economic status of a candidate of high school students, okay, on the type of program they're going to choose. Okay, now if I want to have access to the data, you can copy this from the, you can see that's an online data from University of California at Los Angeles. And when you take a look at when you now do with the table you want to have, let me tell you this. This is the data. This is the code. That is the code. If you copy that into R, you're going to see, and you actually write M1 and you enter, you're going to see the whole data set. But let me categorize, what this guy is saying. From this data, I want to generate a table. And that very table we consider, we cross-list socioeconomic class with program. That's what you see here. It's a contingency table, right? Socioeconomic class has 3 levels, low, medium, high, and the program general academic vocation. What you are seeing here, we just enable you to see how many students for those 16 students, they are into general program and they fall into low socioeconomic status and so on like that. It's just like giving us a descriptive idea of the data. But you know what we want to do? What we want to do is we want to look at the effects of some explanatory variables on the choice of program that the high school student is going to choose. Okay, now if I want to do that, I'm going to show you there's a code now. This is an arrow code. You need to, if you want to work with a multinomial regression, you need to install that package. Okay, NNet. You load it. Now, after doing that, then let me now show you the code to run for multi. I need you to take a look at this. Oh my God. Look at that. What are you seeing right now? You're going to write RE level for multinomial. And you know what I'm trying to do? I actually want to make a level of the response to be referenced. I told you, we got 3 levels, right? Vocational, academic, and what is the other one? Vocational, academic, okay, yeah, and general. Now, I'm trying to tell R, make academic reference. you can decide to make whatever reference. But the one you make reference is the one you're going to be comparing with others. Does that make sense? Okay. Now, after doing that, you see that I use this. This is that guy is representing what I make as reference. Whenever I want to make something as reference, I'm going to write RE level, then write that ref equal academic. Now, if I want to do the module now, oh my God, I'm actually going to, for linear regression, you're going to see LM. For Poisson regression, you see GLM. For binary logistic, you also see GLM. Okay. For binary logistic, even when you see GLM, don't forget in the parenthesis, you're going to see family equal binomial. For Poisson regression, you're going to see family equal Poisson. But right now, for multinomial, you're actually going to write multinom. Okay. Then the program too, on what? You just indicate your socioeconomic class and the and the writing score. Is there anyone who doesn't understand this code? Oh, okay. Oh, okay, I can see. But you understand it now, right? Oh, okay. Okay, now when you take a look at what we have right now, when I do summary into that, please, I need you to pay attention. You know what happened? The way we normally have result for multinomial is different. It's going to give us coefficients separately, the standard error separately. Now, when you take a look at this is for coefficient. And what you reference will not be listed in the output. What do we reference? Academic. Do you see academic? No, there's not going to be academic. So whatever you reference, okay, you actually is not going to be displayed in the output. Now, these are the coefficients. Why do we have these two? Okay, take a look at this now. We're only having these two. Haru has done something. How many levels of socioeconomic class do we have? 3. Haru has automatically referenced the low. Don't forget in the explanatory variable, socioeconomic class is categorical. Haru will decide on the one to reference. But you will be the one that will decide on the one to reference when it comes to Y. Does that make sense? Okay. Now, take a look at that. Now, the next thing is, how do I write the model? For this time, it's okay, write the fitted multinomial logistic regression model. You know what? If I want to write a model, okay, I'm going to use this guy here. For general against what I reference. Then for vacation, I'm going to use that against what I reference. What did I reference? Academic. Now, I'm going to show you the way the model works. Oh my God. Generally speaking, we're actually going to have two models. Why do we have two models? General against academic, vocation against academic. You can see in the two modules, what are we doing? We're actually comparing the other two levels with the one that was referenced. Okay? Now, if you take a look at this guy now, if I want to talk about, if you take a look at this guy, I'm going to write the beta 1 band 0 cap, beta 1 beta 1 2, beta 1 3 this is what I'm going to use for that. Does that make sense? That's what I'm going to plug in. How many of them? 1, 2, 3, 4. That's, I'm actually going to plug them here. I'm going to plug them here for this guy, for this guy, for this guy, and for this guy. How many? Therefore, I will do it for this. I'm also going to do for vocation. Any question on how we write the fitted multinomial logistic regression module? Is there anyone? Okay. Now, the moment you've written down the fitted module, okay, the next thing is how do we interpret? Okay, interpretation matters a lot. Okay, now, for instance, I want to interpret B13. Let's say, for instance, I want to interpret this guy. Okay, B13. And where is the B13? You're going to go back to the module. Okay, the B13 is actually, for general, is this guy, right? This is that guy. Okay, we approximate that, and that give us, let me see, is it a positive or negative? That's a negative, right? Now, if I actually want to interpret that, take a look at this. Look at what I said. I said a unit increase in the variable right is associated with a decrease. Why decrease? Because the sign is negative. Now pay attention, we are back at log odd. Under binary logistic, we mentioned log odd, right? Under Poisson regression, we also mentioned log, I think we mentioned log expected count or something like that. Under beta regression, we return back to normal, the way we normally interpret. But right now in the multinomial, we are back at log odd. Now, in the log odd, now look at the way you're not going to interpret the log odd. Log odd of being in the general program versus academic. Do you see that? Do you see my interpretation right now? Because that guy is only for this. If I'm to interpret beta 2-3, for instance, let's say for instance I want to interpret this guy now. Okay. Now, if I go back, okay, I'm actually going to use this guy here. That's still a decrease, right? And I'm going to say the log odd of being in vocation, which relatively to the academic. Does that make sense? Just like what I said here, the log odd of being in the general program versus academic. That one is going to be the log odd of being in the vocation versus academic. Does that make sense? Okay. Now, how do we now interpret? You know how to interpret a quantitative explanatory variable. How do we interpret the categorical? Because don't forget, this is socioeconomic class, categorical. Okay, now I need you to pay attention. I want to interpret. Okay, I think I just did this for. I think I just explained that for vocation the other time, the beta 2-3. Okay, now, but what I want to do now, how do we interpret the categorical one? Okay, B12. Let's go back to the table. Okay, the B12. Okay, so the B, if you take a look at that, the SE3. Okay, the B12. Okay, SE3. Take a look at this guy. Okay, SESI in general. Okay, now you're gonna see what I said. Okay, I said the log odd of being in the general program versus an academic program would decrease by that. Now would decrease by that. Oh my God! If moving from what? From what the arrow reference, arrow reference low, right? Arrow reference low socioeconomic class, right? Now moving from low to that high. Does that really ring bell? Does that make sense, right? Now, take a look at the second one. Okay. So if you want to interpret all of that, you're always going to say you are moving from low to that, moving from low to that, moving from what you reference to what you're talking about. Okay, look at it. The log odd of being in the vocation program versus in academic will decrease by that if moving from SES low to SES high. And the last one, If moving from SAS low to SAS middle, you're always going to say you're moving from the arrow reference. It makes sense if arrow could make the lower level reference. That's no problem. That really makes sense. Because we want to move forward. We don't like moving backward, whether in a socio-economic spectrum. Does that make sense? But there's something I needed to take note. The multinomial logistic output does not come with p-value. Do you notice that? It doesn't come with p-value. So if you really want to know how significant, you'll be the one that will compute your z. You're still going to do z, which is going to be the estimate divided by standard error. And we can check for the p-value. And that was what I said here. P-values are not included. We can use word test. The word test is when I do z equal the beta naught, the estimate of that divided by the standard error. And don't forget, in the output that I showed you the other time, you have both the estimate and the standard error. Then we can make use of I code it now to get the p-value. Do you know what? I'm done with the multinomial logistic regression.